All right. 7.2. Okay, so we solved systems last week by way of graph. Remember, we graphed and we found the solution, right? The solution was where the point of intersection where they crossed, okay? If it was the same line, remember what we wrote? The same line. If it was parallel lines, remember what they never had a point of intersection, so there was no solution. We're going to be solving simple.
I was drying my
Okay,
hands.
okay, I'm recording and I'm teaching. Just start writing notes. When? Where?
I was drying my hands and then it fell off and I looked in the trash can and I couldn't find it. Like I literally took every single napkin out and it wasn't there.
Okay,
So
go back and look for your ring.
I looked at it and looked like on the floor.
Go back and if you want to look for your ring, you can catch up because I'm recording. You can watch the video later. Solving simple systems. We're doing the same thing today, trying to find the solution, just like we did last week. But instead of by graphing, we're going to be doing it by substitution. So, AJ, I record now all of my videos for anyone that's absent. I don't have to reteach them. If they're in quarantine, we're in quarantine, or if they need a refresher course, they can rewatch it. It's on my YouTube channel. That's why I do this. Situations like a lost ring. Okay, so solving, the reason it says simple is because there is a section on advanced, and that's hardcore. I don't even know if we're going to be doing that. Okay, so we're solving systems by substitution. Again, we are looking for the point of intersection which again is the solution of two lines equations by the substitution method, instead of graphing method. Okay, I'll let y'all catch up. So I told you some kids really love the graphing method. They get it, they understand graphing, they throw it in the slope-intercept form, y equals mx plus b, graph it, and they go. Unfortunately, that method doesn't always work on every problem because you'll start getting these decimal-like answers that are really hard to find. You know what I'm saying? When you're graphing it, it may not hit a perfect intersection. It might be somewhere in the middle. My gosh, that's near impossible. Problems that they give you just for graphing are going to be a lot easier to solve. Did you find it? Okay, good. Now you can catch up. Substitution method, some people don't like because there's a lot more work involved. However, it always works. Where the graphing doesn't, this one, you'll always find the answer. Okay? So, steps. One, solve either equation for either variable. X or Y. Choose the easiest variable to solve for. I'm putting a star there. So solve either equation for either variable, x or y. Choose the easiest variable to solve for. And I'm going to, when we start doing examples, you'll see what I'm talking about. So, whereas with graphing, you had to put both equations into the y equals mx plus b format. Both of them. That was the rule, right? This one, you can solve for x. You can solve for y. And you can choose the first equation or the second one. Whatever's the easiest. Okay. 2. Substitute the solution into the other equation to get the value of one variable. Again, I'll show you examples to help you to understand what that means. So you're going to solve for x or y in either equation. Once you get that, then you're going to sub that into the other equation to solve for the variable. Again, I'm going to show you what that means because right now it's blah, 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 blah. You have no idea. Once I start doing the examples, all of these steps will come to light, okay? But you definitely need these to refer back to. Step 3. Use the value of the known variable. That's in step 2. To solve, move this up, for the other variable. So you're going to solve for x first, and then you're going to take that information and plug it into the equation to solve for the other variable. Like if you solve for x, then you're now going to take that information to solve for y, or vice versa. And then the last one, I'll let y'all catch up, and here's a star. Write the solution or answer as an ordered pair. X or Y. There you go. Now we get to start doing examples. So let y'all catch up. Again, that's a lot of information to take in. A lot of you are probably thoroughly confused. It's blah, 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 blah. Once I do the first example, everyone will go, oh, that's all we're doing. Okay, you got it. So I'll let y'all catch up. Where are you at, McKenna?
4.
Oh, good. Put your pencils down when you are done so that I know you're done taking notes. All right, I'm turning the page over, starting fresh. We're doing examples, page 286, that's right.
That was quick.
Yep, because instead of doing a whole bunch of examples that aren't from the work and then doing this, is going to be like beating a dead horse. You're going to figure it out after just doing a couple of these right here. Trust me. Huh? No, it's pencils. You only need to sharpen one. And I'm going to keep going while you're doing that. So make it quick. All right, so page 286. I'm looking around. Cecilia, open your book. Page 286. All right, everyone ready? Wait for Cecilia, you there? Okay. Olivia, are you there? You got it? Okay. We're going to start at number 5. Okay, the directions say solve each system by substitution. We're going to solve the system by substitution. Something else to enjoy? I do not believe... Okay, so remember last week when we were solving by graphing, either the answer was an ordered pair or it could have been the same line. So we wrote the equation down, remember that? Or if they're parallel, it was no solution, right? Today, they all have a solution. None of them are going to be the same line. None of them are going to be parallel lines. Did y'all hear me? If I'm walking around checking and you have this on your paper, you clearly did not hear what I'm saying to you now. None of these will be parallel lines, so I should not see that on your paper. Everything, should be, I'm looking to double check. Everything should be, ordered pair. Every answer should be an ordered pair. Got it? Okay, so they gave us y equals 3x, and they gave us 4x plus y equals 49. Do y'all see that in your book? Okay, so step 1, solve either equation for either variable, x or y. Choose the easiest variable to solve for. So, here are my two equations. Which one would be easy to solve for either x or y? Raise your hand if you can tell me which one would be the easiest. Come on, y'all. Okay, Taylor?
Y equals 3x.
Yeah, this one is already done for you. So why even mess with this one? You could say, yeah, well, I can move the 4x over there, and then I have y equals, 4x plus. Why? No pun intended. Because this one already is done for you. It's already solved. So I'm going to call that number 1. And this one right here is going to be my second one. And I'm going to show you what we're going to do with that. So we like this one. And I mean, it's always going to be the first equation, second one. But we're going to choose this one again because it's already solved for a variable. There's no work to be done. So we're going to take this 3x. If y equals 3x, we're going to substitute that 3x into this y. See? Y equals 3x. Cecilia, do you see that? Are you awake? They're saying that y equals 3x here, so I'm going to take that and put it there. So now I have 4x plus 3x equals 49. So I'm going to pause right there. Does everyone see what I just did? If you don't, please, even though we have a visitor, you need to ask. This is your grade. Any questions so far?
Can I state something?
No, I said questions. All right, so now we just combine like terms. 4x plus 3x is what? 7x. So I have 7x equals 49. Now what do I do? Raise your hand if you can tell me. What do I need to do? Cecilia. That's right. We're going to solve for x. And because it's being multiplied, we're dividing both sides by 7. So I get x equals what, Cecilia? (49) divided by 7 is 7. Okay, guess what? There's my first part. There's my x, my first part of my ordered pair. So now we can take that and truly, because my students have tested this theory, you could put it back into either equation. Of course, this is the easiest, so watch what I'm going to do. I'm going to bring this equation down so it's nice and neat. So I'm taking this same equation, number 1, first one, and I'm going to, this says x equals 7, so I'm going to substitute that 7 into this x so I can solve for y. So I have y equals 3 times 7. And 3 times 7 is what? That's right, 21. Oh, look, here's my other part of my ordered pair. So my answer is 7, 21.
This is kind of fun.
This is your actual answer. Remember, this is your x and this is your y. So that's what you are doing today.
I like this.
Good. Now, again, so step 1, we solve either equation for either variable, x or y. Choose the easiest one. We could have chosen this one. If you wanted to do extra work, you could solve for y and then take that information and plug it in over here. You could even solve for x if you wanted to. So you could choose either this equation or this one to solve for either x or y. That's step 1. Step 2, substitute the solution into the other equation to get the value of one variable. So we substituted, solved, and got the value of one variable. See how this is now making sense? Step 3, use the value of the known variable in step 2 to solve for the other one. So we take that, plug it in, and solve for the other one. And then, bless you, step 4 is write it in ordered pair. Boom. There's your explanation of all those steps. Any questions? Excellent. Okay, let's move on. All right. Number 7. They gave you y equals 3x plus 2 and y equals 5x minus 6. Okay, this one, not quite on the same level as number 5, but still, both of them have been solved for y already for you. So really, it doesn't matter which one you choose because they're both going to be kind of the same way. So I'm going to rewrite each of them here. Okay, and I'm going to start calling on people randomly to just tell me what to do next each step. So Michael, you're my first victim. Which equation are you going to start with? Okay, he's going to start the first one. So we know that y equals 3x plus 2. What am I going to do with the 3x plus 2? Michael. Of which equation? Okay, so he's correct. We're going to take this, because it says y equals 3x plus 2. We're going to substitute it into the y of the second equation. So now I have 3x plus 2 equals 5x minus 6. Okay. Emily, what do I need to do now? You have to move something. What are we solving for? Eventually. What letter? Yeah, we're trying to solve for x, right? So what could you move over? Okay, and how would I move the 2 over? There you go. Subtracting it on both sides. So I get 3x equals 5x minus 8. Now what do I move? The what? What about this x? Where should I move it? To the other side, right? We got to move this whole term. So how do I do that? That's right. We're going to subtract it. So I get now negative 2x equals negative 8. Now what do I do? There you go. We're going to divide both sides by negative 2. And I get x equals positive 4. Okay, there's my first ordered pair. Before I move on, are there any questions? Speak now, forever hold your peace. No questions? All right, Taylor, what do I do now? Good job, Emily.
So now you plug 4 back into y equals 3x plus 2.
Okay, so he wants to plug it back in here. I'm going to rewrite it because I did all that mess there. So I'm rewriting my first equation, and he's correct. We're going to substitute this 4 into that x because we're solving for y now. So I have y equals 3 times 4 plus 2. Good job. So 3 times 4 is? Taylor?
Oh, sorry. 3 times 4 is 12.
Plus 2. So then y equals what, Taylor?
14.
Now we have our x and our y, so our answer is what, Cecilia? Perfect.
Yeah, I like this.
And I'm putting stars so that I can discern which is the actual answer. Any questions? Not too bad, right? Now, again, these aren't too bad. I got 2 more examples for you before I set you free. If you're done taking notes, put your pencil down so I know you're done. All right. I'm definitely turning the page to a clean page. Hint, hint. Let's look at now, because you know they're not always going to be that easy. Let's look at, oh yeah, this is a good one, 23. We'll see if Taylor still likes it. I'm sure he will.
Yep.
3x plus 5y equals 13. And then x plus 8y equals 36. Okay, I've got 2 lines here. I'm going to go ahead and rewrite them. Nice and neat. So I have line 1 and line 2. I'll let y'all catch up writing that down so that you can pay attention. So, Aiden. Line 1 and 2, we need to choose an equation, 1 or 2, and a variable. That's the easiest to solve with. What would you do?
Choose one and make it like,
Choose this one?
yeah, solve it so it's like substitution.
Solve it for what?
Why?
Y? Okay, so he would choose 1 and solve for Y. Would someone else choose something different? Or would y'all all choose 1 and solve for Y? Gabby, would you choose line 1 and solve for Y? Michael, would you? Taylor, how about you? I'm not saying you're wrong, because it doesn't matter.
If it's what I think it is, then yes.
If it's what you think it is.
If we're okay, never mind. I'm just confusing.
Okay, so you would work all this to solve for Y, correct? What about line 2 and solve for X?
I'm a little bit confused.
Step 1, you could solve either equation for either variable, X or Y. So look right here. X is already by itself, right? Couldn't we choose this equation and solve for X in one step and call it good? That would probably be the easiest, right? And by the way, Aiden wasn't wrong. You can choose literally either one. Let's go with this one. Let's start with, because I want to show you can do that. Let's start with equation 2 and solve for X. How do I solve for X, Aiden?
It's AY.
On both sides. So I get X equals negative 8y plus 36. See what I did there? I'm using equation 2 this time, and I'm solving for X. That's really taking y'all out of your comfort zone. Because you've been trained to always solve for Y, always solve for Y. So now this is saying X equals negative 8y plus 36. So then what do I do with this negative 8y plus 36? This is saying X equals this. So what do I do with this mess?
Would you put it where the Y goes on the other one?
But this is saying X equals all this. Hint, hint. So if X equals all this, would I substitute the X or the Y?
The X.
Bingo. Guys, this time, Michael, you understand? You awake? This is saying X equals all this stuff, so I'm going to go and substitute the X. X equals negative 8y plus 36. Well, I'm going to substitute that X with it. So now I have 3 times, right? 3 times X, so 3 times negative 8y plus 36 plus 5y equals 13. I want y'all to look at that. So I substituted everything that this X says right here, the value of this, I plugged it into this X. It says 3 times all of it. So 3 times all of this plus 5y, I'm rewriting my equation, equals 13. Do y'all see what I did? Does that make sense, Whit?
Kind of.
So before, look right here, before it said y equals 3x. So boom, I'm substituting the y with that 3x. This time I'm saying x equals all this, so I'm substituting the x with that because I'm solving for y.
That makes sense.
Does everyone see that? So now I start solving. What is this called right here? Michaela? we're going to do the distributive property. So 3 times negative 8y is negative 24y. 3 times 36, and I'm helping y'all with your brains on a Monday morning by giving you this information when normally I wouldn't, plus 5y equals 13. Write that down, sit back, take it in. See what I did? I'm rewriting my equation here. Does everyone see? Emily, do you see where I got all this? Now I combine like terms. Michaela, what are my like terms here?
Minus 24y and 5y.
Which will be negative 19y plus 108 equals 13. Now what do I do, Michaela?
Minus 108 on the other side.
Very good. Subtracting 108 on both sides, I get negative 19y equals negative 95. Raise your hand if you have questions. And then now what do I do, Michaela?
Divide by negative 19.
That's right, divide both sides by negative 19. Some of you have already got an answer, I can tell. So then I have y equals negative divided by negative is positive. It's 5. Okay, so I've got one part of my ordered pair. So y equals 5. So then, Gabby, what do I do with, now that I've solved for y, what do I do with it? Okay, so she is going to substitute. We're going to look here. She said, let's take this equation, number 2, x plus 8y equals 36, and let's substitute that y into that y. So down here, for the sake of a mess, I'm going to rewrite that equation. So number 2, I'll write it right here. In fact, I'll bring. Now I'm just going to make it nice and neat. So I'm going to watch what I'm doing, guys. I'm going to take this equation, x plus 8y equals 36. That is equation number 2. Do y'all all see where I got that? Raise your hand if you don't. Emily, do you see that? Cecilia, do you see that? Olivia, do you see that? I got this equation that Gabby chose. I rewrote it to make it nice and neat. We're going to substitute that y right there. So now I have x plus 8 times 5, because 8y is multiplication, equals 36. So Gabby, what's 8 times 5? So x plus 40 equals 36. Now what do I do, Gabby? And I get x equals what, Gabby? Huh? Negative 4. So then, whoops, sorry. So then my final answer is negative 4, comma 5.
I still like this.
Good. There's my x and there's my y. Sit back after you're done, put your pencils down when you're done writing, and then sit back, look over your work. Notes mean everything today. If your notes are messy, you will see it'll drive you crazy.
Could we have like a minute brain break?
For what?
Brain break?
No, I'm saying look over your notes. See if you have any questions before we do the next one. If you need a brain break with simple systems, you should see the advanced ones. All right, but seriously, does anyone have questions? Because after this next example, I'm setting you free. Okay. Here we go. 28. Last one. Because they're all being done the same, you're just substituting and solving back and forth. The only difference is when we get to, the higher numbers here in the next section, you get to choose which equation you want to do. Okay, so we have 2x minus y equals -4, and then x plus y equals -6. Okay, I'm going to call 2x minus y equals -4, line 1, and then x plus y equals -6, line 2. Aiden, I'm coming back to you. It's okay. Aiden? Now, in this case, really, it's up in the air as to which one you do. 1 or 2, x or y. So, which one do you want to do? You want to do number 2 and solve for? Okay, he wants to solve for y. Okay, so he wants to do this. You could solve for x. You could even choose line 1 and solve for y. Either one, I kind of am with Aiden. This has like less numbers, and so it's like, okay, let's start here. But really, you could even try it out. It doesn't matter. You could solve for y. Do you see where I'm going with this? All right, so he wants to solve for y. So Michael, how do I solve for y for number 2, if that's what we're doing? That's right. We're going to subtract the x on both sides. So I have y equals -x minus 6. Any questions before I move on? All right. So now we know y equals -x minus 6. So then, Emily, what do I do with that? Substitute this into what equation? The first one, in which letter? There you go. So she's correct. Because this is, we solve for y, and it equals this. We're going to now substitute it into that. Now, be careful. Look at this negative sign. 2x minus, in parentheses, look what I'm doing. -x minus 6 equals -4. And y'all check my math, make sure I'm doing this right. So 2x minus, and then we put this in there, -x minus 6 equals -4. Does everyone agree with that? Anyone have questions? All right, Taylor, what do I do with this negative sign right here?
Distribute the property.
And so what is my new equation?
2x plus x plus 6 equals -4.
Perfect. You're distributing the negative is basically what you're doing. So this -x becomes a positive x. This -6 becomes a positive 6. Good job. Cecilia, what are my like terms? 2x and 1x. Which gives me what? 3x. Perfect. Plus 6 equals -4. Aiden, what do I do?
You subtract 6 on both sides.
I get 3x equals negative what? -10. Are y'all with me so far? Whit, what do I do now?
You're going to divide the 3 on both sides.
And guys, in this case, you do not have to put it in a mixed number. You do not have to put it in a decimal. So x equals negative 10 over 3. We now have, we now have our x. Good job. Any questions? Okay, Michaela, what do I do now with that x?
You rewrite number 2.
Okay, she's going to choose the second line, and I'm going to rewrite it right here for the sake of space. So she's choosing this equation, and I did rewrite it just like she suggested to make it nice and neat. I'm going to draw a little line so that you understand. Okay, so what do I do with this? Michaela?
You move the x that you just got into the x on number 2.
That's right. So we're going to substitute this x with the value of this one that we just got. So I have negative 10 over 3 plus y equals negative 6. Now, Gabby, what do I do? We're going to add 10 over 3 on both sides. So over here, remember, that's negative 6. I'm going to write it in red. Plus 10 over 3. We're adding fractions. So, Gabby, what do I need to make sure they both have? Common denominator. So what would the common denominator be? 3. So I have 10 over 3. What would this one be? Perfect. So then my y is what, Gabby? And there's my answer. So then my ordered pair is negative 10 over 3, comma, negative 8 over 3. And there's my final answer. Any questions? Y'all ready? Y'all wait. Does everyone have this down? I'm going to wait till everyone's done, pencils down, and you've taken all in and all questions have been asked. All right, you are doing page 286, numbers 6 through 20, even. That's right. Honors, you're doing 10 through 24, even. And all of this is due Tuesday. That's right. That's all you're doing. Your quiz is still probably going to be Wednesday, but I'm considering moving it to Thursday or Friday, so just be ready. All right, get started. Lights, please. And I'll walk around.
Preparing for next lesson.
Right. Here you go. Take care.
You too.
So say you're leaving at 3 today for a doctor's appointment.